Next up, we have Scada 401, PLCs and VFDs. We have, and forgive me if I mess up your last name, Akshaya Selvaraj from Arcadis. Like I said, she's an INC Scada design engineer and has been with Arcadis since 2015. And Ross Gambino, deputy leader at Norwalk WPCF and has worked for Viola since 2020.
Good afternoon, everyone. Like the gentleman said, my name is Ross Gambino. I'm the deputy leader at the City of Norwalk Water Pollution Control Facility. And one of the things we've really worked on at our site with our client and the municipality is upgrading our Scada system to be more efficient, to help our operators get real-time data and also be able to track that data throughout our different databases, through our company and through the availabilities with Arcadis, and Aaron and Associates have played a huge role in that. So we're going to get started right now, and I'm going to turn it over to Akshay.
Thank you, Ross. Okay. So Scada is maybe I'll just clear my name. I'm Akshaya Selvaraj with Arcadis, INC engineer. Worked with many of you here, but we've also done the design for the Scada upgrade at Norwalk WPCA. So I'm going to give a brief overview of what Scada is before we dive into the details. Like, as you may know, and you'll be working with Scada on an everyday basis. So Scada stands for Supervisory Control and Data Acquisition. So in simple terms, it is like a web page or an application that's sitting on your computer, only that it helps you monitor and control your process. So it gives you a visual representation of what's happening across your plant. Controls can be at different levels, right? So let's say you walk down to the pump station, you turn on the pump from your local control station. That's your local control. But alternatively, you walk back to your control room, you sit and operate your plant from there. Or you can be at pump station A and you operate pump station B. So that is all done via your Scada HMI, right? So with the data that is all coming in, you can also store it and use it as a historical means. So you always have the ability to see your trends. You have the ability to see what happened, what went wrong. You want to see, okay, what was a wet well level like 10 days back. So all that is facilitated through your Scada system. But when we say Scada, it's not just your HMI that you're seeing on an everyday basis. So HMI stands for Human Machine Interface, right? So Scada is an overall system. So let's say bottom to top approach, you have all your field instruments. You have your flow meters, pressure transmitters, gates, valves. So all those relay back signals, so all those get tied into a control panel, right? So a control panel will have a controller. I mean, there are various types of controllers. It's just that in our industry, we typically use PLCs. So the PLC would sit in the control panel where all the signals from your field instruments come into. And as a design engineer, and typically as good practice, what happens is each process area might have a control panel with the PLC. So your aeration tank system might have a control panel with the PLC. Your influent pump station might have another one. So you have like various PLCs sitting across your plant, and everything is networked, right? So the PLCs talk to one another, everything is networked. And finally, all of that report back to your HMI. So all this actually comprises your Scada system. So it's not just the application that you're seeing. This is really, am I doing it right? Yeah, maybe. Okay, so this is just an example of a PLC, which you might have seen already. There are various manufacturers. We're just going with a manufacturer here, but it's going to look like a brick. You have the same chassis, you have a power supply, you have your I/O modules, you have your COM card. So all of this helps integration with the field instruments and reporting back to your Scada system as well. And they typically sit inside a control panel, which you must have been familiar with by now. So the top one, the circled one, is your rack of PLC. And of course, the control panel has various other components as well. And these PLCs talk to one another and going back to your Scada system. So when we say a Scada upgrade or Scada improvements, what are the key drivers that is actually rooting for a Scada upgrade? You're not going to wake up one day and think, okay, we're going to do a Scada upgrade. It's not going to happen. So there are like key drivers or factors that kind of push us for a Scada improvement at every plant, and that's what design engineers work with you guys to figure those out. So typically those are categorized under like three divisions, I would say. One is obsolete equipment. Your controllers, your PLCs, network switches, servers, they may all be outdated. Or at least it's not supported by the manufacturer anymore. So it's like your phone, right? So it changes every year, you have an update every time. But PLCs and SCADA, you don't have to change it every year. It's not that, it's not that finicky. But if it's 5 years, 10 years, 15 years, 20 years, maybe it's worth reconsidering, right? Because a lot has changed since then. So with obsolete equipments comes your issues with security as well, because it is no longer supported, and the new cybersecurity and all that cannot be implemented on the older systems. So that is one key trigger to go for a SCADA upgrade and go for a newer system. The next one is technology improvement. When we say technology, like everybody might have a HMI, and it might be 10, 15 years older. But believe me, like the latest HMIs or the SCADA packages that's out there has a lot of better features that the operators can actually take advantage of. And with respect to alarm management, with respect to how you get your alarms on your phone, on your email, or even like dealing with mobile SCADA. So there are so many features that the recent HMI applications give you, which we can take advantage of. So that is another major push factor. Third is just overall like process enhancement, right? So you know that you want to revise that strategy. You know you want to better the way the pump is acting, and you've been like stalling that for years, because and after a point you have like various processes that needs an overall control strategy upgrade. So maybe now is the time to take advantage of all of that, and that's what triggers a SCADA upgrade. So where you can accomplish all these in a single project. Okay, so but implementing and delivering a SCADA upgrade of significant automation changes and like large capital cost is difficult.
This is supposed to be up here. Someone moved it.
Thank you. Wait, can you hear me? Yeah. So it is a very challenging task, but, am I clear? Yeah. But through the various implementations that we've done, and there are some lessons learned, a lot can be accomplished way ahead in the design phase itself for a successful startup, right? So interestingly, what we found is this is facilitated through a design-build approach for the SCADA upgrade project. So what I mean by that is, in a typical, let's say, a design-build approach, so you have various parties. You have the consultant, the design engineers, you have the contractor or the integrator who's doing the configuration itself, and you have the owner, you have the plant operations, right? So all these different parties in a traditional design build scenario doesn't work together at the same time. Whereas in a design build approach, this essentially gives a one team concept where everybody is involved from day one to, so basically from design through configuration, through deployment to startup, everybody works as a single team, and that's the approach we followed for Norwalk upgrade as well. So what we did is, in this design-build approach, let's say just like this picture, so we involved all the different stakeholders, like the contractor, engineer, operations owner, everybody was involved from day one. So we used to have like n number of workshops, n number of like roundtable conferences like this, where we went and took, let's say, the first one was, okay, go through each control strategy, right? Each process we actually literally went through documents of control strategies. We got input from operations. We got, because the engineers were there, so we were able to tweak the strategies in theory. And then we took out the alarm list, like the existing alarm list. We went through each point. It was hundreds of alarms, but it's a huge nuisance when you have like alarms that are incorrect. So we went through the alarm list. We discussed, okay, is this required? Is this not required? Is this a nuisance alarm? Is this even a working point? So we went through all of that with an entire team. So of course the contractor was there while we were doing all this. So with these information were kind of like handed over to them, and they went back and did their PLC programming and the HMI development and all that. And then they would come in and do a simulation to the plant operations, to the engineers with the same team. So they would do a simulation where they would show, okay, this is what we discussed, this is a new implemented strategy, and this is how it's working. So that gave operations a lot more insight on, you're not seeing the HMI for the first time after it's deployed, after it started up, and then you see, I want to see this, so instead of a surprise factor at the end, so all these workshops that happened up front kind of gave the operations a more, they felt heard, I think, and we got actual feedback from the operators, okay, I would like to see this here, I would like to see that there. And instantly we were able to make those changes because we had all the parties there. So this helped in terms of training as well. So when the system was finally started up, it didn't feel new for the plant operators, and because they were already involved from the beginning. And this considerably reduced our startup time. Of course, the cost involved with all of this, and I would say, in terms of, because we're all on the same team, right? So ultimately, we want to reduce cost, be efficient, and reduce time. So this approach kind of helped with all of that. So, and I think I'll just touch base a little bit on our work, and then I'll hand it over to Ross, because Ross and his team has worked a lot with the system that we implemented, so I think he would add some value to see what's happening. So at Norwalk, the reason we went for a Scada upgrade is, like we mentioned, all the drivers that we were looking for were there. They had obsolete equipment, 20 years old, networking switches, they were all old, no security put in. The HMI was still on an older platform, single server setup, no redundancy. So all those triggers were there to go for a Scada upgrade. So typically what we do as design engineers when we have a owner asking for a Scada upgrade project, so we walk in and we collect data through site visits and talking to them, looking at record drawings and all those. We create something like an improvement matrix where we list everything. So these are all your improvements that you can do at your site, right? It's not just your PLC replacement or just your Scada, even process-wise. You could improve this process. So we create a list. And not all of that needs to be done and get go. So you can phase it out, and that's what we did. So based on what are your essential upgrades? What can be reused? How much cost we have for year one? So this happened in phases. So right now I think we're in phase 3 or phase 4, Vanessa, right? So it took really 4 or 5 years to get to this phase 3, but we laid the foundation back then. So, and we had n number of discussions. Again, here all the parties were involved. It was not just the design engineers making the decision, right? So we had operations, we had owners. So we kind of okay, these are the 10 improvements we are going to focus on. And that's how we came up with the 3 improvement heads, right? Network, panel, and Scada upgrades. So Norwalk had a big network upgrade. So they used to be on, for people who know, their entire older PLC system was on DH plus network, which is no longer supported. So everybody's on Ethernet or Modbus these days, right? So we redid their entire DH plus network. We did a fiber ring, so now it's all on Ethernet. With the fiber ring, there are advantages. You lose a link, you can still talk to your other processors via the other link. And we heighten their security on their switches, servers, everything. So this is very important because once you have that foundation set up, you can scale that to a big solution later on. So we did all that. So now what they're doing at Norwalk is they implemented a mobile Scada. And now even if you have remote stations on radio or cellular, it's easy to integrate because the backbone of the network was done back then. So that was a major upgrade that was done on the network side. Panel upgrades, when we say panel upgrades, we don't need to completely demolish a panel. And sometimes your panel might be in good condition, your wiring is good. It's just that the PLC or the processor is outdated. So what we can do, and this actually saves cost also, is we can just gut out the PLC and put a new one, but keep the panel, keep all the wiring as is. So this saves on cost and time. And that was, again, implemented at Norwalk. So I was mentioning about how you can reuse existing infrastructure because that, again, saves cost and time. So even when we, let's say we move that DH plus network to fiber, the facility already had duct banks and manholes between each buildings. Conduit runs were already there. So we didn't dig up any new, unless until required, we kind of reused all the existing manholes, all the existing duct banks, even for the fiber network. So we didn't spend millions to, just to dig out and put a new conduit. So wherever possible, we reused your existing infrastructure. And it is very difficult in a live plant. So we cannot, just because a SCADA upgrade is happening, you cannot shut down the plant for a year, right? So you need to keep the plant running while you're doing the upgrade. So we kind of did a parallel. Everything was on the older network while we were creating the newer network, and then we kind of moved one after the other to the newer network. And for a long time, for months, the operators were working on two SCADA networks, the old system and the new system, while the transition was going on. And this was possible only because of proper planning and all those integration with a design-build approach where we had everybody together. Third item was SCADA upgrade. Of course, we overdid the entire HMI was moved to a new platform, better alarm management, I think. And we laid the foundation for a mobile SCADA. Then we didn't implement it the first year because it was not priority. But now I think they have it. They like it. I would want Ross to talk a little more on that. Okay. So with that, I want to give to Ross. And you've been working with the team on the SCADA upgrade, right? So do you want to say a few words?
Hello. So basically, the Veolia team and the WPCA City of Norwalk team have really come together with Arcadis and Aaron Associates to figure out what every entity and party involved in this decision-making wanted. We met, like I said, with workshops, and we each gave our 2 cents. Two of the things that our operators are really happy about and the city came to was the new total screen, because now we can go in and we can download a report for our flow, what the pump run times were for the day, and we even have the ability to make it into 15-minute increments. So that allows us to get a better knowledge of the data on a consistent basis and daily basis. If you can notice, you'll notice the total screen right here. It's right here, and it shows, oops, excuse me. And you can see what we're able to look at on a daily basis. Now, as an operator, or somebody who used to be an operator, and now I'm a leader, this data is essential, especially if we have a wet weather event, if we have a pump that's not running, we can trend it, we can look at it, and these are the kind of things with the upgrade as a team we've been able to create. The other thing that I really like is our Scada mobile app, and that's actually back one slide, so if you'll excuse me. It's right here. You'll see this. We also have all of our pump stations available on both the desktop version and the mobile version of our phones. So I can be anywhere in the world and I can see what's going on at the pump stations and the facility in real time. That ability as an operator or as a manager or as a team member, being able to monitor your pump stations and what's going out in your city, not only as much as what's going on in your plant, it gives just so much value to the system as a whole. And we can share that with other municipalities, how we were able to, advance the system. Arcadis really put a lot of time in with Veolia and the city, as well as Aaron Associates, to do this. Another big upgrade we were able to complete this year was incorporating our centrifuge OIT, which is on a completely different system and different code. We were able to upgrade our SCADA and our dewatering screen, as you can see, to have the centrifuge controls on the desktop version in the control room. This makes it greatly easier for our operator who's on a single shift or a solo monitoring shift like the overnight to be able to make process adjustments to the centrifuge while being other places in the plant, because you can't be two places at once. In the past, the operator would have to stop what they're doing, go make an adjustment, come back, wait for it to work. In here, they could do it. There's 4 different SCADA stations all over the facility. There's one in this building, there's one in the control room, and there's 2 more in separate offices where they have access to. So they really can be anywhere in the facility and be able to look and make adjustments. That's, to me, that was one of the best things we were able to do this year. So the other, we developed SCADA standard upgrades for future programming. We allowed ourselves to be able to leave room in the boxes, so if we wanted to add other OITs, like right now, we're working on a wet weather hypo pump situation, we're able to use an existing OIT, because we have space in the panel and run the wire. It makes it more efficient, it makes it easier. We can review all the alarms for going back as many days as we want, and then the Win 911, which are critical alarms. So basically what Win 911 is, it's attached to SCADA, and let's say we get a high level at a pump station, or just a pump shuts off or something, that's very critical. We'll only get an email, we'll get a text message from 911, because sometimes an operator's out taking DOBs, they're checking DOs, they're not gonna be in front of the screen to see the alarm come in. So it'll ring on their phone and they'll be able to address it immediately. The remote station enhancement we've done, we've added backup floats to our pump stations, because some of our older pump stations aren't allowed, they don't have the capability to transfer to new PLCs yet, and they're working on upgrading them. So we installed backup floats and we tied those into SCADA to give us an alarm. And SCADA server is being able to, we just have enhanced the whole process, and it's been really great to be part of the team and been able to do it. So, I mean, I'm for just SCADA as an operator, monitoring, and being able to just get real-time data for your team has made Norwalk a more efficient project, and I've been so blessed to have been able to be part of the team and help. So I'm going to turn it back over to her. Thank you all.
Thank you, Russ. I think in conclusion, what we are saying is SCADA upgrades are important. It's huge, but it need not be daunting. So I recommend you try different procurement approaches for these type of projects specifically, because it is not like your typical process upgrade. So I know we took Norwalk as an example today, but we've tried multiple approaches, right? As a company and as a team, we've done traditional design build approaches. We've done design build. We've had integrators as a sub to us. We have done turnkey approaches. Sometimes the design engineers we have configured. So we've done various things for various municipalities. And I recommend you at least explore into the different procurement options when it comes to something like a SCADA or PLC upgrade. It gives you a lot of flexibility, and have a vision, right? So it's not gonna get done in the first year or the first month, depending on your budget, your capital cost, what's essential. So it's gonna take years to get there, but have a vision and whichever procurement approach you take, try to engage all the stakeholders as early in the game. So that has helped a lot. That has been our biggest feedback. And proper planning should make it seamless. So that's all we've got to say. Thank you. Any questions? Oh, yes.
Was there spare conduit available for the fiber optic run?
Yes. So most of the duct banks had spare conduits. There were some locations where we didn't have, and we kind of used the same manhole to manhole, but had to have a parallel conduit put in. But most of, so that's where record drawings make a big, we did verify the as-built, whatever was available, right? We started with all the as-built drawings, record drawings, and we did actually go to the field to verify how much of it is accurate. And only after that, we were even, we made a plan. So, but yes, most duct banks had 1 or 2 spare conduits for sure.
Question.
Sorry.
So are there video cameras that you can tie into and see what your thickened or dewatered sludge looks like?
To that point, thank you for that question. We have video cameras placed in all the critical processing points of the facility. One of them is in our dewatering building where the centrifuge and our GBT is. So we can see the consistency of the cake dropping into our trailer, what's coming off our GBT, how does it look. We can look at what the filtrate looks like. So if we want to zoom in, we're able to zoom in on the filtrate and see what we're actually, what the polymer release is and all that stuff. So we have two ways to monitor the facility, cameras and the SCADA.
So I just want to add something. So when you're trying to implement cameras or mobile system or anything with remote connections, you need to have your network done right. So Norwalk actually did a cybersecurity analysis. So once we put in the new network, they actually ran a cybersecurity threat analysis. So we knew, okay, which switches needs to be configured better. So how is the traffic like and all that. And we put in like secure VPN networks for operators. So it's not like anybody can pull up a phone and get connected to their server. It's not like that. So you have to have access. It's restricted. You have a VPN system. And we tighten everything on the switches. So right now, even if he's operating it from home, he's using a secure mobile device with his username and everything. It's not open to the public at all.
Any other questions?
Can I just ask, like, most of your plants must have Scada systems, right? So is it old system, or anyone had a recent upgrade in the last 5 years, 10 years? Or would you say it's on an older system?
Well, for us, we have an iFix system. We did one software upgrade in 2014, and we've done a lot of, upgrades as far as the controls, the screens. But again, I think maybe that's a lot with my peers is that, like, if you want to see something, you want to pull in a different variable to read on the main screen. We've done a lot of that type of work and tweaked things to make it more user-friendly. But again, we're in the middle of doing a facility plan, and we know that the iFix that we have is obsolete. And even with the computer system, like you didn't mention the computer systems, but we're using Windows 7.
Oh, yes. OS is a big thing,
If you ask other plants, like what are you using? Now you're up to 11. That's a whole nother question that you got to do when you do a Scada upgrade.
Because even if you go with iFix or any other platform, the newer applications don't support Windows 7 anymore. It needs to be Windows 10 or above. So yes, that's one thing. Yes, please.
Did your Scada incorporate process control, meaning ORP, DO controls that adjust blowers?
Yes, we monitor all that. And we had an instrumentation upgrade about 2 years ago, and it just is finalized last year. And we measure DO, and we actually have the Scada set points so that if something changes in the process, the DO will adjust based on the process, based on the DO, and the blowers to turn up. We have an ORP probes, ammonia, nitrate, all that stuff. So we're able to see in real time what's going on. There's regular maintenance, regular cleaning, and calibration that needs to be done, but our team's very efficient in doing those things, so it makes it easy to see those parameters.
Okay. Vanessa, do you want to chime in on anything? She was the PM on the project.
Perfect. They are. They are.
Okay, thank you very much.
Thank you, guys. All right.